So the first machine learning problem statement is it's a kaggle bike sharing data set, which basically stores the sales data, and it's aggregated at a daily or hourly level. So each hour I can see how many sales have been made through registered user, through casual user, and what is the total count of sales happened in a given particular hour. At the same time, it also stores the data at hourly level, like what is the weather at that time, what is the temperature, what is the humidity, what is the wind speed, what was the season, and so on. And basically the objective of this exercise is to build a model which basically can predict the sales or the total count of sales in each hour. So going forward, so whenever I input my input data, it can tell me in the next hour or in the coming hours how much sales I'm expecting to have. So basically we need to build some kind of a regression model which can tell me the total count of sales in a given hour. So let's jump into the Python notebook and see how can we build this model for the bike sharing. So let's start on developing the model on the Python notebook. I have included all the packages, whether it's a Panda, Seaborn, XGBOOST, train and test split, and so on. At the same time, I have also uploaded the dataset. So there are two datasets what we have. One is the training data, other is the testing data. So basically we will use the train.csv file to build our model. We will split this file into training and the validation data so that we can validate the performance of the model. And once we build the complete model and we are convinced that this model is really good and is meeting some of the business expectations or exceed the benchmark of some of the important metrics, then we basically run this model to evaluate the numbers on the test.csv file. So since I have already uploaded both the files, so let's see what is the data we have in this file. So let's start with df.train.head. And we can see the quick snapshot of this training file. We can see that we have around 10 to 12 features, which includes some of the independent features like daytime, season, holiday, working day, weather. So this data is aggregated at an hourly level. So at each hour, you will know that how much sales have happened, what was the temperature in that hour, humidity, what was the wind speed, whether it was a holiday, season, and so on. And our target variable basically is the count column. So you can see the last column is the count, which is our target variable. So that is the column which we need to predict once we build the model. So we can see this model, we can see this data. Now let's see what is there in the test file as well. And we can see in the test file we don't have those the target variables like count or casual or registered. So basically that is the objective. Once we build the model, we will run that model against this test.csv file, and the model needs to predict the count, which is our target variable. So for the simplicity of this exercise, we will drop the casual and the registered column because that is we don't need that column. We are considering our target variable as count. So let's do basic data profiling and some kind of a data analysis to get the feel of the data, what kind of characteristics are there in the data, what kind of some important trends we can figure it out, or some important insights. So I think so the first thing what we can start is to see the how many rows and columns are there in our training file. So we can see that we have around 10,886 rows, and we have like a 12 columns. So now let's see some kind of a descriptive statistics of this particular data. And I prefer to do the transpose of this so that it can be easy to see, like season, how many rows are there, what is the mean value, standard deviation, and so on. And if you see the count, the count mean value is 191, whereas the median value is 145. So we can see that there is a difference between their mean and the median value. So probably the count variable is more like a skewed we can see during our graph, and if you feel that there is some kind of a right skewness or a left skewness, maybe we can think of transforming to a different feature. And similarly, we can see the temperature as well. The mean temperature is around 20 degrees Celsius, as well as medium is also around 20 degrees. So more or less it's quite same when it comes to mean and median. And we can see the max values of each of the column. We can see the count, the maximum sales which is happened in 1 hour is around 977. So this is how we can see some of the descriptive statistics for this data set. Now let's see if there is any if there is any missing values or not. So we can use a function like is_null.sum. And the good thing is that there is no null values in the data set, so maybe we can move ahead with the next step, so we don't have to worry about its missing values. The next thing what we are planning to do, as we discussed, that we will drop these two columns, which is registered users and the casual, because that is this number it doesn't require for our model building, because we are taking count as one of our target variable. And if you see the count column, if you see the value of a count column is basically a summation of casual user plus registered user. So 16 equal to 3 casual and 13 registered, which is 16. So typically we don't need the casual and the registered, we are more focusing on the count side. So let's drop these two columns from our analysis. Casual, and then we have a registered user. Then x is equal to 1 in place. And let's quickly see that this column have been dropped, and we can see that those two columns have been dropped. Now during our descriptive statistics, we saw that the count has some kind of a skewness, because we can see the count mean value and the median value has some difference of 46 points. So let's see on the graph, does it make sense or not. So we can use some of the plots like Seaborn library, and let's say I'm using this plot, and let's plot the count column. And we can see that the data set here is little skewed on the right side. So probably let's try out and transforming this column into some different feature, and let's see if it can make it more like close to like a normal distribution. So the easiest way we can start with the transformation is through log, and np dot and then count column. And when we run it, although it's not very close to normal distribution, I mean it's not like an exact normal distribution, but it looks like a very close to a normal distribution, at least much better than what we saw in the previous graph. So maybe just remember that when we do the feature transformation or feature engineering, we will convert this target variable from count to log of a count, and that we will use as our target variable. Now let's do some more analysis and see how the sales look like in a different season. So what we can do is to create like a box plot. So in the box plot we can put like a season here on the x-axis, and then on the y-axis I can plot it our count column, which is our total number of sales, and obviously data equal to df underscore. And we can see that for season 1 we have a very less number of sales. Probably this season 1 could be a winter season, because of the extreme winter conditions, people might not be taking up the ride. But as compared to if you see season 2 and season 3, which has a high number of sales, probably this could be more like a spring season or a summer season when a lot of people are coming and taking up the bike ride. And similarly on the season 4 as well, we can see there is a drop in the sales. Probably it might be that end of maybe a summer season or some other season, and it's a beginning of a winter season. So we have seen some decline in the season 4 as well. So it means that we have a good percentage of sales during season 2 and season 3. Next, let's see if there is any kind of a trend present on the timeline chart. We can see on that So before that, let's check the data type of each of the column and make sure that our date column is in the right format. And when we see that date time column is in the object, which is more like a string format, we do need to convert them into a time format so that we can plot it on the time chart and see some kind of a insights or a trend. So what we can do, we can use we can convert this column date time using the pandas date time function, and then we will pass date time. And this column has been converted. Let's confirm it, and we can see now that date time has been converted into a date time column. Now let's extract, because the date what we have got in the training data, it's like a combination of date, complete date, and a time. So what I'm planning to do is to extract the month and year from this date, and let's see if we can find some kind of a trend across different months or between years. So for that, let me create a new column called year, and then I will pass df_train dot dt and the name of the column, which is date time dot dt and dot year. And similarly we can do for month as well. And let's run it and see few samples of this column, of this data set, and we can see that we are able to extract the year and the month. We can see 2011 and 1. Now let's plot it the timeline and see if there is any kind of a we can see some kind of a different trend across different months. So for that I am planning to create a plotting a line chart. On the x-axis I will be plotting month, and then on the y-axis I'm plotting the count, and then our data would be df_train. Now here I'm using estimator as equal to sum, because I want to aggregate the total volume of sales across month, because as we know that our data is aggregated at the hourly level, but I want to see my sales aggregated at the monthly level. So for that I'm using estimator is equal to sum. And hue is equal to year. So I'm also planning to see how my sales looks when we compared across different months. And then confidence interval I'm putting equal to false. Now here we have plotted the graph, so we can see this pinkish chart is for 2011, and then those blackish dark line for the 2012, and we can see that we have a huge shift in the increase in the volume of sales for 2012. And we can also see that across months as well. For months like starting from maybe April or May and then going till October or maybe August or September, we have seen an increase in the sales. Probably these could be like season 2 and season 3, where we saw that season 2 and 3 has a high number of sales, and we can see and we can validate from this graph as well. So it means that we have a high volume of sales when it comes to season 2 3, which is typically fall into across months like starting maybe from April, and then it goes till October. So now the next thing we can check is the correlation. Is there any kind of a correlation between target variable and some of the independent features like weather, temperature, or humidity, or wind speed, and so on? So let's plot some kind of a correlation chart and see if there is any kind of a trend we can figure it out from here. So I'm picking, let's say, weather as one of the column, then temp, let's say a temp, another could be humidity, and let's say our target variable, which will be count. And let's plot it on some kind of a chart. and we are creating the heat map and passing our df underscore core variable, which we have calculated in the previous cell, and annotation is equal to true, so that we can see some of the correlation values as well. And plot dot show. Now we can see this heat map or a correlation values, and let's focus on the count column or our target variable. So we can see with count temp the correlation is 0.39, although it's not very high, 0.39, but still there is some kind of a relationship between temp and the count, and which we have already seen in some of the previous graphs. With increase in the temperature, especially in the summertime, we have seen a jump in the number of sales. And when we see the humidity is like inversely proportional, so it means that whenever humidity gets increased, we tend to see a drop in the number of sales. But again, both temp and the humidity numbers are not that very high, but still we can see that there is a correlation between temp and the humidity. So let's plot another graph, like for example, let's say scatter plot. So we have already seen that there is some kind of a relationship between the temp and the target variable count, and let's see with the scatter plot as well. So let's plot x. On the x-axis I'm plotting temp, y-axis I'm plotting count, and then data I'm passing df underscore train. And we can see, as we know, that there is some kind of a linear relationship between temp and the count, but it is not that very strong. And we can see on this axis as well, the moment the temperature starts increasing up from 15 degrees Celsius to probably 30, we have seen a linear increase in the number of sales. And when the temperature gets increased to more than 32 or 33, we have seen that the volume of sales starts going down. So it means the temperature between 20 to 30 is the one which typically we gets a lot of sales. A lot of customers comes and take the ride with us. Now I think this would be a good set of analysis, and we got a good idea about this data set. So let's do a quick feature engineering thing. And as we seen in one of the previous analysis, that our target variable is kind of a skewedness on the right. So let's convert that column into a let's convert this column into a log form. And this column has been converted into a log form. Now the next step is, let's start building the machine learning model. So first let's build our training and validation data, and we will split on 70 and 30. So 70% would be our 70% of the data will be a training data, and 30% would be a validation data. So on the independent features or our x variable, we will drop our count column, as well as I will drop the date time column, because that's the column which is not required. And then x is equal to 1, and then y equal to, I'm passing our target variable, which is count. So y basically will store our target variable. Now here I am splitting our training training data into 70 and 30 split. Y underscore train underscore test underscore split function, and then passing x and y, and then I'm doing test underscore size equal to 0.3, so that we can get a split of 70 and 30, and then random underscore state equal to 100. And the data has been split into 70 and 30. Now the next step what we can do now is to build the regression model. So, and we will use the XGBOOST to build the model. We have already loaded the packages for it. And here I am basically taking two parameters only. Two hyperparameters would be maximum depth. Let's say I'm going with a 5, and number of estimators is equal to 100. So basically a very simple model. with 2 parameters, and now I'm fitting this regressor dot fit, and then x underscore train, then and the evaluation set would be our x train and y train, and then x underscore validation and y underscore validation. I think I have put it wrong. Okay. Yeah. So x train and y train, and similarly I can put x underscore validation and then y underscore validation. And we can see the model has started working now, and on the left it's showing about our training root mean square error, and on the right it's showing the validation root mean square error. And let's plot a graph, because I wanted to see if there is any kind of a overfitting or not, or is there any kind of a variance or a bias in the analysis. So what I'm doing now, I'm creating a variable called evaluation underscore results, and then the name of the model what we build, regressor, and then I'm passing evaluation underscore result. Now I'm creating a training rounds. Now this particular code will basically create a plot, and it will showing me what is the training error and the validation error, because that is very important to understand, to see if there is any kind of a bias issue, underfitting, overfitting, variance, and so on. Let me remove this S. And we can see that there is a gap between training error and the validation error, but it's not like a huge error. There is some sort of overfitting here, but I'm okay with it for a time being. And now next step is to predict on the validation data. So regressor dot predict function, I'm passing x underscore validation, and we have calculated the predict. Let's see how much is the deviation between the actual values and the predicted value on the validation data. It's on the validation data. So let's say difference predict minus y underscore validation. So now let's predict this difference on the histogram, and I want to see if there is any kind of over predictions and under predictions. So what I can do is use the sns.histplot, and then I'm plotting diff. And we can see that it's centrally surrounded around the 0, which looks like more like a normal distribution. And it seems like I have on the both the axis on the negative side, as well as some of the error rate on the positive side as well. So since it's circulating both on the negative equally, so it seems that model has done a decent job in learning some of the trends, and I'm not seeing any kind of issues like if the model is over predicting or under predicting something. So I think this model looks good in my end. I think the next step what we can do is to run this model now on our test data. So we can run on the test data. So the way we can do is to let's first see df underscore test dot head. And since we have already removed the column like date time, so let's remove the column date time. But before removing the date time column, we want to convert this and extract month and year, because month and year are part of our training data. So let's first convert this column date time. Let's first convert this column into date time feature, and then we will extract df underscore test month dot dt dot month, and similarly we can do for year as well. So let's put it a smaller place, and now it has been converted. Now our df underscore dataset, df underscore test have been extracted, the month and the year. Let's now drop this particular column. So in this way, now we have dropped the column. So now our model is regressor. So now let's predict the count value. Let's say count underscore. Let's say include this count underscore predict in the test column as well, and let's see the sum of its values. Let's say and the count predict has been done. So another one thing which we remember, we have converted our count column in the beginning into log form. So the output what we are getting count underscore predict in the log form. So now we have to convert back into its original form. Maybe we can take a exponential thing. So df underscore test count is equal to np.exp and then count, and let's print some sample values just to make sure that we are getting the right output. Sorry, there is no count, so let's replace count underscore, and we can see that it has been converted. Although some of the values are coming in the decimal, but it's okay. We can put it like, instead of 122.4, we can take a round as 122 or maybe 123. Similarly, we can take it as 78, 179, 248, and so on. Another thing what we can do is to see what are the feature importance steps. So let's say xgb dot plot underscore importance, xgb dot plot importance, and then you will pass the regressor, which is the name of our model, and then it will tell me the rank of the features or the importance of the feature. So it's telling that humidity, wind speed, temp, month are some of the very important features to consider. Maybe as a next step, if you want to improve the model performance by further, maybe we can take only some of the important features, maybe humidity, temp, wind speed, month, and then rerun this model and see how the model is behaving now. So another thing what we can do is to find the root mean square error as well, because we have not checked the root mean square error during this step. Let's check the root mean square error as well and see what is the accuracy is coming on that, or what is the metric is telling about that. So the next step is, let's find out its root mean square error, and let's print its value. Let's format it well, root mean square error, passing the 0. And now I'm basically using the package metrics, and under metrics I'm basically finding the mean squared error, and I'm passing our pred and y underscore validation. So prediction pre, this variable basically storing all the predicted values on x underscore validation, which is our 30%, and y underscore validation is basically it's our actual, and then I'm taking the square root of it, so 0. Sorry, the spelling is wrong here. And we got the RMC of 1.21, which is very high, which doesn't seems to be very good, but that would be our next step. We saw some of the important feature importance variable, for example humidity, wind speed, temp, and probably as a next step we can use only these 3 or 4 top variables, recreate the model, redesign the model, and see if our root mean square error and some of other metrics are improving or not. So that's pretty much this is how we can quickly build a model in less than 30 minutes, which include all the important steps like feature analysis, data analysis, exploratory data analysis, EDA, how to build the model, what kind of model we can use, how can we evaluate the performance of the model, as well as understand what is the importance of features. And based on that, as an action step or a next step, we can take the subset of features and rerun the model and then compare the metrics with the old one and see if we get any kind of a lift on it. Thank you.